It's network forensics, which is very important, and it's the first thing I think we're going to do in this class that does not use autopsy. The tool for this one is Wireshark. And analyzing network traffic is extremely useful in many areas of technology and security. Pretty much every company has to have somebody that knows Wireshark just to diagnose problems on your own network. Whenever somebody cannot log in or can't get service from a server, you run Wireshark at both ends. What is being sent, what is being received, and then usually it's a firewall or routing problem, but that's how you diagnose it. That's whenever you're struggling with networking issues, which is extremely common. It must be 3/4 of all the problems my computers have is networking and virtual machines. And so Wireshark is extremely useful. And of course, it's also useful to investigate breaches. Because the attacker typically comes from the outside, and then they typically install agents that call to the outside, and then they move laterally through the network, and all these create network traces, and network traces are a good place to go. So there are also things that monitor the network for known bad traffic, like RSA, NetWiki, Carbon Black, Splunk. Wireshark is the main one we're going to use here. These EtherCap, Scapy, wget, curl, these are all tools that can measure network traffic in various ways. So proxy servers are an important kind of device to understand. For example, my website uses a proxy server, samsclass.info. When you load this page, you are not loading it directly from my server. And you can tell if you go to terminal and you do dig samsclass.info to see what the IP address is. I have two IPv4 addresses. And if you dig for IPv6 addresses, I have two of them also. And none of these are actually my server. And you'll get different answers at different times of day and different answers in different locations. They're all Cloudflare. And if you can tell, if you do the dig start of authority for me, you'll see this Cloudflare. So Cloudflare is a reverse proxy. It sits in front of a server, so all the traffic to go to the server goes to the proxy, and you look at a copy of the page on the proxy. Yeah, it's a great free service. It protects you from DDoS attacks, and it increases the bandwidth of your server. So I have one cheap virtual host that's IPv4 only and HTTP only. And Cloudflare adds HTTPS and IPv6 to it and makes copies of it all over the world, so everybody can load a local copy and protects it from attacks, all for free. So that's a reverse proxy in front of a server. The other kind of proxy, a forward proxy, is in front of the client. So if you are at a company like City College and you go to a website, instead of going directly to the website, you go to the proxy, and the proxy fetches the website for you. And this way, if there's something the college wants to block, like games or porn or something, they can block it at the proxy, and you can't get it, because none of your machines can go directly to the internet at all. They can only go to the proxy, and the proxy will only fetch sites that match its policy. So that's a very common service used at a lot of companies, so they get more control over what people are doing on the internet. So a URL is this unique identifier up here, and right. And when you send a request to a website, you typically get 200, which is success. You asked for something and you got it. The first thing that comes back is always a status code. If you get 300, that's a redirection. This page has moved, and it automatically goes to the next page. And 400 is an error, can't find this page. 500 is a server error. It ran a script at the other end that created an unexpected output. When you're hacking into servers, setting up things and getting code injection and stuff, you often get 500 when it works, because it sends out a result which is not the expected result. All right, and 100 is informational. You can have scripts running in any kind of language on the server. This is Python, PHP, Perl. There are many, many other languages in use for websites. Website designers, professionals typically know something like 20 languages. It is bloody insane. And typical websites have many different technologies working together on them, which creates a security nightmare. And let me just check for comments on the Twitch. Nothing new. Okay. All right. So DHCP. Every time you boot up a laptop, it connects to the wireless network, and then it gets an automatic address. Your address determines where you are physically. If you move to another room, then you need a new address. Now, typically you have a local address like 192.168.1.100, which is not an internet address. It's a local-only address, but it gets passed to a public address at the router. And if you move to a different location, it has to have a different public address to deliver the package to you, just like your physical mailing address. So that's what DHCP automatically determines these addresses. And if you come back and reconnect to the same network, you might get a different address. So you need to keep logs of these. If you don't, then you cannot tell what IP address matches to what physical object. So if you find out a machine is infected and it's a laptop, you have to have DHCP logs to find out where it goes. Email service, of course. Forward email with SMTP is what sends email from server to server. POP and IMAP are technologies to download email from the server down to your client machine, and they're hardly ever used anymore. Now pretty much everybody uses web-based email like Gmail, where the email just stays on the server all the time and you never download it to your local machine. These things were developed decades ago when server storage capacity was not big enough to hold the email. So you had to clean it off the server, delete it, and store it on your local machine. And that's no longer necessary. DNS servers resolve domain names like ccsf.edu to IP addresses. This has to happen or you wouldn't be able to use alphabetical names to get anywhere. And almost everybody uses domain names, even for servers, because IP addresses change a lot. If you have a server running somewhere with an IP address, you often move to a different host or something, and then the IP address changes and you can just redirect your DNS to point over to the new place. There is a local file on your machine called the hosts file. I should be able to see it on here. Yeah, there's the hosts file on this Mac. And you see it's got it determines local host. There's nothing else here except I had to add this because archive.ph, which is a useful it's part of the Internet Archive site. It's a site that will let you bypass paywalls, but they hate, I think, OpenDNS, or they hate some of the public DNS servers. So if you go to use the public DNS servers, you can't find them. So I had to hard code it to address here. Then in the early days of the internet, this is all there was, and they would actually mail floppy disks around, and there was just a list of domains, and IP addresses just went in a flat file like this. It's still in your machine, but it's not normally used. Although I had to use it here to get around the strange limitation of archive.ph. So routers connect different networks together, so they can lift a packet off of one network and move it onto another. And therefore they have to have a routing table knowing which direction to send packets. Switches connect devices on a LAN by layer 2 addresses, MAC addresses, not IP addresses. And hubs are an old technology, essentially extinct now. Before there were switches, there were hubs that were dumb devices that would take every frame sent to them and just repeat it to every other device. However, Wi-Fi does that because they can't do anything about it. Wi-Fi is non-directional, so every frame you send goes to every device in the neighborhood, whether you like it or not, amounting to the same thing as a hub. Switches are faster and better, though, because they memorize the MAC addresses plugged into every port, and they only send traffic to the right wire. So you don't send extra copies of it down other wires going to the wrong device, which makes them faster and prevents collisions. IDS is a system that analyzes your network traffic for known patterns of attack and blocks it. Or at least the detection system would alert you of it. The IPS would block it, the prevention system. And firewalls have rules of some kind to limit traffic. The early firewalls just limited by port number and IP address. Modern firewalls look at all kinds of things like the Active Directory group of the client receiving it, the known content, and all the games, all the porn, all the social websites, you can block them by category, and so on. They can recognize BitTorrent no matter what port you put it on and stuff like that. They use sophisticated analysis of the entire packet to compare it to sophisticated rules to decide which things are allowed and which things should be blocked. So PGP was the original email encryption. It uses RSA encryption. It's very strong, very, very hard to use. So even the people that invented it pretty much quit using it. The problem is you have these private keys, which you have to read your email, and you have to never lose the private key, and you have to have it with you. And as you move from one machine to another, you lose your private key. I have like 6 of them out there. I've lost them all. People are sending me encrypted email. I'm never going to know it. And this, even the people that designed it found this to be an insurmountable problem. IPv4 and IPv6 are the two addressing systems. If I do ifconfig en0, my wireless card, I've got an IPv4 address here, 172.17.31.182, and this is an IP version 6 address. It's much longer and it's in hexadecimal. And it's 4 times as long as an IP version 4 address, so there are an unthinkable number of them because we ran out of IP version 4 addresses. And because there are only a maximum of 4 billion and really something like 2 billion usable ones. And we have far more than that many computers on the internet, but this is much, much bigger, so we will never in our lifetime need more than IP version 6 to have enough addresses. And there are MAC addresses too. The MAC address is the physical address coded into your network adapter, which is intended to never change, although you can change it in software, people usually don't, so it's a unique identifier. It is 48 bits long. Then you got ports. When you connect to a remote server, if you do netstat -an pipe more, you'll see established connections like this. So here is my local address on port 63085 connecting to a foreign server on port 443. This is an HTTPS established connection. These four numbers form what's called a socket, a local address and a port, and a remote address and a port. And once you've done the TCP handshake of SYN, SYNAC, ACK, you've established a socket, and now the two devices can communicate as if they had a wire of their own. Their communication is not completely private, but it is addressed in a way that I can send packets to this service on the server, and it'll be picked up by my service on my machine. And as you can see, I have various connections to various places on different port numbers. That's just to sort it like mail. So these are the different browser windows or something, taking up the data. All right. Now there are the OSI and TCP models are just two models of the layered structure of networking. In the very early days, like in the 70s, when I got my first computer, you would have to buy a computer, and then you'd have to buy a printer, and then you'd have to buy a word processor that could talk to that printer. And if you wanted to talk to a different printer, you had to buy a different word processor that could talk to the printer. Everything was proprietary. And then I have standards and layers. So now you have, for example, a network card. All the network cards are interchangeable because it's well defined what they do. They only handle layer 2. The routers are all interchangeable. They only handle layer 3 and so on. By defining these roles and defining the layers of the stack, you can have a separate device or software piece to handle each job, and you can interchange them. And that come from the OSI and TCP models, are the models of layers that specify how you define the different activities that have to go on when you send or receive network traffic. Let me check for comments on Twitch. MAC addresses. Airlines limit 20 minutes of free wireless based on MAC address. Yep, absolutely. Yep, changing your MAC address is often a way to get another bit of free service, that sort of thing. Yeah. When the college first put in their wireless network, they filtered by MAC address, and they gave each of us 2 MAC addresses. And I had like 8 devices, so I just changed them all to the same MAC address, which I made AA, BB, BB, BB. And then I told all my students, and my whole hacking class used that MAC address everywhere on campus for about a semester until they finally busted me because it turns out that's not valid. I didn't know that. The first bit has to be 0. A is not valid. But I got away with it for about a year before they got upset at me. Anyway, it's
Isn't it like about the average time it takes for something to be detected, like a year or more?
That's true. Well, it depends. You know, it's about a year when people notice they've been hacked. Yeah, to notice minor anomalies like this, I think many people never notice at all.
Yeah, I mean, like for an enterprise environment, that's kind of scary.
Yes, but the problem is legitimate traffic has all kinds of weird things in it. So if you run something like Splunk and you see all this weird stuff, it's really hard to decide what means anything. That's why I remember UC Berkeley, I told them about vulnerable machines and machines that were hacked and doing malicious things, and the network administrator said, I can't do anything. I tried blocking obvious viruses on network, and then people called, that was our research project. We were deliberately sending viruses over the network. And he's like, how am I supposed to clean anything up if you're going to be like that? He said, we can't block anything. But most people can block things because they don't have people doing stuff that crazy on them. Anyway, all right. And voice over IP has replaced old-fashioned telephone systems where all your telephone call is done with IP packets. And therefore, they sold this by telling everybody you can save money by sending your telephone calls over your existing wiring. And then when you bought it, you all found out that that was a lie, and you had to upgrade your existing wiring because voice over IP needs really fast pack and a lot of traffic. So anyway, what I've heard is it costs something like $1,000 a seat to upgrade to voice over IP, but people do it because it's so good to have all the advanced features of say press 1 for this, press 2 for that, and forwarding your calls to elsewhere and stuff. Those all turn out to be very valuable. And almost everybody's using voice over IP these days, except home users. Home users still have normal phone service. So I guess cell phone calls don't have voice over IP exactly. So let me check here. All right. Okay, it's an instant response. I mentioned before, this all came about because of 2010. China hacked Google, and Google exposed it all, revealing what people in the security industry had known for 5 years, but it hadn't been publicly disclosed, that China was hacking every American company and establishing permanent presence on them and stealing all their stuff, and all the existing security devices were not stopping them. And they exposed that, and there was a storm in the security community, and over the next few years they invented the new paradigm where you have network security monitoring and instant response, because you accept that all your prevention devices will not stop the more powerful attackers. And you have to have more layers of security behind that to pick them up. So the instant response team notices that a bad thing is happening on your network, analyzes it, and then goes out there to go through the stages of first declaring an incident, then containing it so it stops spreading, then researching it to find out exactly what's going on, and then cleaning it up, and then patching the vulnerabilities so that those people can't come back the same way again. That's the ideal way to do it. So it can be quite a job. And a lot of people don't have that kind of staff, so what they do is they hire consultants, and the number one consultant is Mandiant. They basically invented modern instant response, and all the big corporations hire Mandiant. They will fly in a team of people that will spend weeks analyzing your network. They will charge you a pile of money, and that's what you do when you're a big company and you get hacked. They're the experts. They're like the people after an airplane crash that come in and pick up all the pieces and figure out what made the airplane crash. That's essentially the same kind of thing going on. All right, and threat intelligence is more and more important. It used to be, until maybe about 5 years ago, most people would say, I don't really care who hacked me. All I care about is how did it happen and how do I stop it. Now more and more people do want to analyze who attacked them, for example, because they're often attacked with ransomware. And then you need to hire a consultant that knows the reputation of the ransomware groups, so you can decide whether it's worth paying them, and or whether you can negotiate with them. And people learn the customs of the groups, and they can give expert advice on how to deal with them. So this threat intelligence is knowing about what criminals are doing, and there's more and more sharing going on. CISA is a big source in America now of useful threat intelligence, which is very good because legal restrictions have made it very difficult for American companies to share data about anything.
Did they just hack recently?
I think CISA did have some kind of security incident, yeah. No, everybody does. That's one of the disturbing things about this business is no matter how much you spend on security, some people can still get through. All right. So APTs started in 2010. When China hacked Google, Mandiant analyzed it and wrote up a report and called them APT-1. They were the first publicly recognized advanced persistent threat, which is a naval term, but it is basically enemy military. People who are powerful enough to penetrate all your defenses and sneaky enough to hide on your network for a long time and you won't detect them. So they're persistent. They'll hide on your network, stealing your stuff in a subtle way so you won't even notice. And so then that was APT-1, was one of the groups from China, and then they had many more. And now there's a lot of them out there. And so APTs are the groups that come in. Now, Lockheed Martin did something called the cyber kill chain to try to organize thinking about this. This was the earliest step. You have reconnaissance, where they learn about your company. Then weaponization, where they prepare some kind of attack. Then they deliver the attack. Then they exploit your service so that somebody deliver it with like a message, somebody clicks on a link, then they have control of some machine. Then this machine calls out to command and control servers and exfiltrates data. That was the cyber kill chain at Lockheed Martin. And this has been greatly enhanced to turn into the attack method. This is the modern version of this, the MITRE attack framework, which instead of having like 6 groups like that, it has 14. So you have reconnaissance, then development of resources like gathering cloud servers and such. Then they have some form of initial access. They're able to get somebody to do something, take some control over some device on a network, like somebody will click on a link in an email. Then they gain execution on some device. Then they have to have persistence so that when that device is rebooted, they won't lose control of it. Then privilege escalation to move from a local account to administrator or domain administrator. They have to evade defenses like antivirus. and they have to steal credentials to move around the network. So they will search this machine for password hashes or other credentials they can use. They do discovery of your network, scanning from one location to see what they can now reach, because networks are segmented and firewalled. So if you scan from the outside, you'll only see the public things like the email and web server. But once you get inside, you'll see more. And every time you move to another machine, you'll see more and more as you penetrate into the network. And that's lateral movement, as you take over machines one after another, tracing your way through the network. Then you collect whatever you came to collect, which might be credit card numbers, PDF files. Then command and control is when you have external servers controlling bots inside the network, sending control signals back and forth. Exfiltration is moving data out of the network, which is often quite difficult because the good stuff is usually several layers in, and it's hard to steal and sneak out. And then whatever other impact you might have, like, for example, physically breaking things, wiping servers, doing whatever your mission was. And therefore, not all 14 things are done by every attacker, but they try to organize them this way so you can organize your thinking, plan your defenses, plan red team engagements, and so on. This is the modern way of organizing your thinking around the steps that attackers do. So reconnaissance involves looking at job postings, looking at your company from the outside, press releases, comments on tech forums, and weaponization is preparing some kind of malicious code, delivery. We talked about all this. So, and these things are called tactics, techniques, and procedures. These are the things that identify an enemy. So,
Why is it TPP?
it should be TTP, shouldn't be TPP. Yeah, it should be TTP, you're right, that's a mistake. All right, so Yara is a popular tool which just scans files and looks for patterns of characters in them to classify malware. So it's very simple, it's essentially no more than grep. People make a big deal out of it for some reason, I don't know. We talked about persistence. DIL side loading, we're doing it in the malware analysis class. This is the number one way you gain execution on Windows machines, is because Microsoft uses a technique called dynamic linking. So you're running a program, and then it wants to have a library, so it adds the library while the program is running. So you can trick it into adding the wrong library, and now you've been able to inject attacker code into the process. So remediation is when you fix a risk in some way, you lower a risk, like blocking an IP address at the firewall, disconnecting systems from the network, or so on. Then you analyze the infected machines to find indicators of compromise, which is something you can easily measure that will tell you if this machine has been compromised, like a file or a network packet or a registry key or something that you can easily detect that tells you if this machine is part of the attack. Then you can scan your network with tools like Velociraptor and see how many machines are infected. And then you plan your remediation activities and perform root cause analysis. The number one mistake people make from tech support, when a server gets infected, they just re-image the server. There, now the server's back up. Now, if it was just like a mechanical fault, like a hard drive failing, that would be the right action. But in instant response, that is not the right action, because if you find one infected server, it probably means there are many other problems on your network and many other malicious activities going on. So instead of just fixing the first one you find, you should research the network to find out what's really going on, how big is the problem, and how did they get in. And that's what this is. You do root cause analysis, then you plan an eradication event. It might take you a couple of weeks to gather all the data. Then you have a single eradication event where you re-image all the infected devices and you close all the vulnerabilities they came in with. And if you're successful, that actually kicks the attacker out and they stay out. Often you're not successful because your analysis was not accurate enough and they had other backdoors you didn't know about, but that's what you have to do. But just fixing everything as soon as you find it accomplishes nothing. That just warns the bad guy that you're onto them, and they will now just deploy more malware and dig in deeper. All right, so those are indicators of compromise, anything you can easily measure, prefetch files, so on. All right, and so you can look in the RAM. If you look in the RAM, you'll find running processes and active network connections, and that's often where the good stuff is. It's often not on the hard drive in a modern attack. Shim cache is a place that'll show you what applications have been run, and shell bags will tell you what folders have been opened. And so you can get a record of what people have been doing. And volume shadow copy shows you old versions of system files and other files on the machine. So if people overwrite files, you can see the old version, and sometimes that helps. So here's some, Carbon Black is a popular endpoint protection tool from VMware. Kibana is part of the ELK stack, which is Security Onion. Elasticsearch, Logstash, and Kibana are open source tools which put together amount to approximately Splunk. That's what the open source people use, Elasticsearch, Logstash, and Kibana, to create an open source imitation of Splunk, which is much harder to use but cheaper. And log2, I think this is something you'll try to make a timeline of log files. SANS likes to talk about it, and SANS uses this thing called the SIFT workstation. SANS is a training company that has excellent classes, but they are very expensive, and the materials are not public. So they have their own version of Linux they like called SIFT, but all the training materials, how to use SIFT, cost money, so I don't use it. But the classes are very good as long as your boss is paying for them. And they have a bunch of certifications too. They're very well respected. Essentially, all my advanced security classes are essentially imitations of SANS classes. All right, so let me see if there's any comments here. All right, let's try for Cahoots. I should have some of them. This is lecture 8. All right. This is 121. I gotta go here. All right. Mod 8. There we go. All right, so what does the hosts file do? Right, it does DNS resolution. It converts domain names into IP addresses. All right. So which device sends all packets to every host on a network? That's hubs. Hubs do that. Now, I see a lot of people not getting this stuff. If you don't know this stuff, you should take 106, Network Plus. Network Plus. This is the essentially Network Plus chapter. Anyway, all right. All right, so which attackers come from hostile military? APTs, the advanced resistant threats. All right. And what phase of the attack communicates with an external server to get instructions? Military Command and Control Server, another military term. All this stuff comes from the military. It's all like stuff.